Hello friends, today we are going to discuss a very important chapter of class 10, that is circles. Now there are few definitions regarding this chapter, so we want to discuss these in the beginning of the chapter. Look at these definitions. The very first definition is secant. Look at this definition. Let me take a highlighter. I am talking about this secant. What is secant? A line which intersects the circle at two distinct points is called a secant. I can show this secant here. Look at this. In this figure, this is a secant line. If I mention it through this AB. AB is a secant to this circle whose center is O. Now the second is tangent. Look at this tangent line. A line meeting a circle only in one point is called a tangent to the circle at the point. You can see here this line CD is meeting the circle at this point. Let's say it is P. So this line CD is called tangent to the circle at point P. Now the next is length of tangent. Actually the children are facing problem in this. So means how much is the length of a tangent. Now look at this. Let's say from this point, from point R, the two tangents are drawn. One is RA and second is RB. Because tangent is a line, tangent is like this, means you can say it ray is a better word for it. It is a ray. It is starting from point R and going till infinity. So what is the length of this tangent? Length of tangent means from this point, initial point, to the point of contact. So this this length from here to here, it is known as the length of tangent. Similarly, this RB is the length of tangent from point R. Are you getting it? I hope you are getting it. Okay. Now, there are few things we should remember that for the tangent of a circle or the tangent to a circle, there is no tangent passing through a point lying inside the circle. Suppose a point is lying somewhere here. How can you draw the tangent? See, whenever you try to draw a tangent from this, let's say this point is R, right? Or if R we have taken already, so let me rub it and we will take another point for this. Let's say some point we are saying the point is M. Point is M, right? So M point, can we draw the tangent from point M? You try your best, but you can't do this. So there is no tangent passing through a point which lies inside the circle. This is my first. There is no tangent passing through a point lying inside the circle. Second one is there is one and only one tangent passing through a point lying on a circle. As you can see here, so this is the only tangent. If you try to draw another tangent at point P, so you try your best, but you can't draw another tangent. See, if you try to draw, it will become a secant. Okay, the third point is there is exactly two tangents through a point outside the circle. You can see this case from point R, two tangents RA and RB are drawn. So if you try to draw one more, let's say you are trying with from R and it will go like this. So it is not a tangent. It is not a tangent. Are you getting my point? Okay. So there are only two possible tangents from outside the point. If the point is outside the circle, there are only two tangents which are possible. Okay. Now the fourth is the maximum number of parallel tangents to a circle are 2. What does it mean? What does it mean? The maximum number of parallel tangents to a circle are 2. Okay, look at this. Say one tangent is this CD. How many more parallel tangents parallel to this CD you can draw? You try to draw, but all these are becoming secant, but there may be one more tangent which is parallel to this given tangent. You can try with this, right? So there are exactly two tangent. The maximum number of tangent, if they are asking, you can say one. This one is parallel to this one, but the maximum number can be two. It can't be more than two. So that is the fourth point. Maximum number of parallel tangent to a circle are two. Now the fifth one, the pair of parallel tangents to a circle are the pair of parallel tangents. Okay, look at this. See, one pair of parallel tangent is this. You can draw one tangent here and the tangent parallel to this from this side. So you can say this is another pair. You can draw one tangent here and opposite to it you can draw here parallel to this, right? So there are, if you are saying, see, how many pair of parallel tangents can be drawn? So answer is infinite. What is the maximum number of parallel tangents? It means there are two, right? So these are the few MCQ questions which CBSE regular ask these, right? Second is, after this there are two theorems which are very important in this in this 10th class CBSE curriculum. Look at the first one, which is a very small and easy theorem. The tangent at any point of a circle, the tangent at any point of a circle is perpendicular to the radius at the point of contact. Means, say a circle is given, let's say its center is O. O is the center of the circle, and this P point, at point P a tangent line is drawn passing through P. Let's say the name of this tangent line is AB. AB is the name of this tangent line, right? Which can go in means endless, right? Okay. Now, so the tangent at any point of a circle is perpendicular. We see the tangent is AB at point P, right? And you have to prove that this radius is perpendicular to this tangent at the point of contact, right? Are you getting my point? Tangent at any point. So what is the point here? Point is P here, P. So tangent is perpendicular to the radius at the point of contact, right? Now you know there are 5 steps of a theorem. The first one is a statement which is given in the question. Second is given. Given means you have to write according to your figure. Don't write the philosophical things here. Write according to your figure. What is given? A circle with center O and a tangent. Now, the construction, take a point Q on AB, means this point is Q. This point is Q. Let's mark it as Q. Q is a point on the tangent AB other than the point of contact P. Other than the point of contact P. Therefore, Q lies outside the circle. As you can see here, Q is lying outside the circle. I can show you. We are talking about this point Q. We are talking about this point Q. Let OQ intersect the circle at R. Let us mark this point by R. This point is R. Let OQ intersect the circle at R. Let OQ intersect the circle at R. Then OR is less than OQ. Why? Why OR is less than OQ? As you can see, OQ is OR plus something. So we can easily say OR is less than OQ. Then and you know this OR portion is equal to OP because both are the radii. Both are the radii, right? From 1 and 2 we can say that OP is less than OQ. OP is smaller than OQ. Why? Because OR is smaller than OQ and OR is equal to OP. So we are saying OP is less than OR. Now, Similarly, if you take some other point, let's say you are taking a point T here, right? Similarly, you can say for this point also that the length of this OT is greater than OP. Length of OT is coming greater than OP. Right? So again OP is smaller than O2, OT. If you take some other point, let's say this side of this, right? And say you are saying is SOS, you can see that this OS is also greater than OP because OS is radius plus something, right? So we can say OP is smaller than OS. You take any point on this line AB other than P, that distance will be greater than OP. So we can say that OP is the shortest distance. OP is the shortest distance. But you know, the distance of a point from a line, shortest distance is the perpendicular one. Are you getting it? The minimum distance, the shortest distance of a line from a point is always perpendicular. So hence the theorem. Look at this, what is written. The shortest distance between a point and a line is the perpendicular distance. Therefore, OP is the perpendicular to AB.